It's another beautiful day in Sydney. I'm out enjoying the sun and looking to find out if anyone knows why the sun shines. So the sun gives us a lot of
heat,
yeah,
sunshine,
provides energy.
Yeah,
heat
gives us
energy.
life, really.
Where does the sun get that energy from?
I have no idea.
I have no idea.
some kind of chemical reaction.
Yeah, gas explosions.
Doesn't it burn gas?
The burning of gases.
It's burning up.
Fire.
The fire that's on the sun?
But is the sun really a giant ball of fire? I mean, wouldn't it go out after 5 billion years?
It's one of those things that you just assume you know, but then you don't actually know.
So in this bucket, I have the components of the sun. Well, I have protons and neutrons. There's some electrons, but I didn't bring them.
Okay.
Yeah. Most of the sun is actually protons.
Okay.
And so what do the protons do in the sun?
It dance together.
Okay. But when they come close, you know what they do? They just
Collide.
Well, actually, they bounce off each other. I'm coming in. Whoa!
Oh.
Why do the protons bounce off each other?
Something to do with electrons?
Positive, negative
electrons.
Because they don't like each other.
They don't like each other.
That's what it is.
That's because a proton needs a neutron, right?
Do you know why they repel like that?
Magnetic force.
The repelling magnet type thing.
Magnet field,
Electric field.
Positives and negatives.
positive and negative.
It's to do with the positive negative, right? We got protons. Protons are
Positive.
So the
Positively charged.
yeah. So the positives repel each other.
Negative charge.
Okay. This is why it's so important that the sun's hot, because if the sun is hot enough, it gets these things moving so fast that sometimes they can't avoid a collision.
Okay.
And when they get too close, they actually go.
An explosion.
goes everywhere.
All right.
Smash the protons? Yeah. No, smash. Oh! And now they're stuck together. And you saw what happened when they smashed together. What happened? They leaked.
Is that energy?
Yeah.
Sick.
Well, the water poured out, but I guess energy would have poured out. Yeah.
The energy came out.
The energy came out. What was the energy before it was energy?
Kinetic energy. Stored energy.
So
Right.
what's happening there?
It's releasing some mass by colliding.
And that mass is,
It's converted into energy.
it was the mass of the protons. When the protons smashed together, they got lighter.
Yeah.
And they lost that mass, and the mass was converted to energy. You know a famous
yeah.
equation about that?
Yeah,
E equals
E
MC squared.
MC
squared.
Yeah.
E equals MC squared.
E égale MC2.
Have you heard that famous equation?
Which? Protons makes energy?
Well,
E equals MC squared, yes.
so what's E?
The sun, I don't know.
E is energy, M is mass, C is...
Cassidy.
Carbon? I don't remember what C means.
So C is the speed of light.
Speed of light? No. Right? Really?
Yeah.
Oh, I thought it was
Isn't that
something
weird? The speed of light.
Right.
Ah.
Wow.
Wait, no wonder we dropped science.
It seems most people have a tough time remembering that C is for the speed of light. Maybe that's because C is a bit of a strange letter to represent a speed. In fact, in Einstein's original paper, he used the letter V for velocity of light. But nowadays, everyone uses the letter C for constant. It's a constant of the universe, the speed of light. Though some people claim the letter C stands for celeritas, the Latin word for swiftness. What is that equation telling us about energy and mass?
Energy equals constant mass.
The mass and the energy combined together create the energy.
It's basically saying, like, this mass that comes out gets converted to a lot of energy. And the speed of light is a huge number.
Yeah.
So you think about that, tiny bit of mass is a huge amount of energy. So every second, the sun is actually losing 4.3 billion kilograms. Every second. That amount of mass is being converted into
Energy.
In the sun, hydrogen fuses together to form helium. But that's a little confusing because how out of only protons do we create a helium nucleus which has 2 protons and 2 neutrons? Well, the thing is, when the first two smash together, one of the protons actually emits a positron and a neutrino and quickly becomes a neutron. Next thing that happens is another proton smashes in. And again, we get more energy released. Now, if 2 particles like this collide, they emit 2 protons, and what we're left with is the helium-4 nucleus. There you have hydrogen fused into helium. And a lot of mass lost, a lot of energy released.
If you want to know more about fusion in the Sun, check out this video by Minute Physics. It explains how the protons can fuse, even though they're not really going fast enough to overcome their repulsion.
Quite hot enough for fusion will fuse together anyway. And the Sun is so big and has so much hydrogen that these small chances happen all the time.